Hello, everyone, again. Welcome and thank you for joining. I'm really excited about this session because for me, it's something I was going to present in English during some period of time because literally this topic really hurts quietly because people love running Kubernetes today, but sometimes or even never, they think about costs. So today we are going to talk about how easily clusters can start draining money in the background, and more importantly, how to regain the control under everything happening in your environments. So ideally, at least it's my expectations, by the end of this talk, you will have real steps, practical, theoretical, which you can apply tomorrow in the morning on your project, even start applying. Not everything can be applied in one day, unfortunately. So actually, my name is Alex Dovnar. I'm the head of DevOps at Naviteq, and my background overall in the industry is around building and operating cloud-native infrastructure for different clients, different sizes, and mostly in clouds like AWS and Oracle, where Kubernetes builds today, especially when we need to scale fast and really, I don't know, wide, yeah, to have from one replica to 1,000 replica in minutes, Kubernetes builds can easily reach six figures a month, easily. So over the last few years, we at Naviteq have been helping teams to cut their Kubernetes costs. In average, something from 20 to 60%. It depends on the complication of the exact case every time. So everything I will show today, I'll share with you today, comes from real production experience. The good, the bad, the ugly, everything as it is, but for sure without concrete clients' references. So, and as a kind of preamble for this meeting, while we are sitting here on the webinar, clusters which we own, built sometimes in the past, are spending money right now, really. Maybe it's running idle pods, oversized nodes, or we've forgotten to turn down some environment or uninstall something after testing. It's like, that's reality. So let's find out how to stop that burn, ideally. First of all, I'm going to do some kind of quick context recap because not everyone on this call, I think, knows about containers, orchestrations. If all these people from outside of Naviteq are non-technical, I will do this call for our HR girls who are also here. So then we will move to real pain, like Kubernetes cost challenges. Then I will share with you some kind of mistakes which I highlighted during working with our clients. And we see daily, monthly, regularly on dozens of clusters, especially with clients we just start working with. Then we will talk about automation, scaling tools and approaches, which really help to save money, to optimize your workloads. And then we will talk a little bit about monitoring and best practices in general, and wrap up everything, not in the end, somewhere in the middle, with some kind of non-technical challenges, like how to adopt Kubernetes. It's actually something came to this presentation after some question on the LinkedIn post about this webinar, actually. So again, as I mentioned before talking about everything, just to be on the same page for everyone on this call, we will fastly go through some basics to understand what we are talking about. Because if you don't understand what is Kubernetes, containers, scaling, it will be really hard to explain the pain and give some kind of, I don't know, insights what to do with that. So containers, actually, it's something which live with us for a long time. At the nutshell, containers, it's some kind of lightweighted micro VMs. I know that some people on this call who know what are containers can just start throwing tomatoes in me, but in reality, it's something for wider audience. It's self-contained, portable, and incredibly fast to start packaged application of you. So containers work because they share something called Linux kernel instead of virtualizing the entire operation system of the virtual machine as classic virtual machines do. So this is why containers with us, because they can start, I don't know, 100 replicas in seconds. But at the same time, when something scales easily, it can also overscale easily. If we don't control it, it should in our leg. So every optimization begins with understanding that convenience equal responsibility. So we cannot just take one tool, adopt it and say, yeah, we are like on the good road and tomorrow we will be, I don't know, fast and cost efficient. No, every implementation requires responsibility. It's like some kind of Spider-Man words, but anyway, I think that you understand what I mean. That is why we love containers today, because it works perfectly great locally and on production. It's isolated, secured, and again, it's fast in scaling. Next question, what are container orchestration platforms? Basically, orchestration platform like Kubernetes, because I think that today we have only one Kubernetes, but on the next slide, I will also name some kind of options. Automates everything around containers lifecycle. Scheduling, self-healing capabilities, service discovery, access control, security, everything is under Kubernetes responsibility and maintenance, and control, how it runs, how it starts containers. So without some orchestration platform, managing thousands of containers will be really chaos. It will be really big challenge and big problem, which I don't think that we want to even try to tackle this. So today we have also few options like Docker Swarm. It sometimes can be really simple for serious production, but some really small projects sometimes start with that. I don't recommend it because I don't think that it has the future, especially if you want to grow. It's not really scalable. Nomad, it's really a niche player. Today it's still existing, but from what we see, it's fading away. Some clients still use that because of specific features they need from that, which is not provided by the Kubernetes. But still, it's not the case today. And Kubernetes today become de facto standard. I don't think that someone can argue with that, but it is the fact. It's reliable, extensible, and automates almost everything. But when it's configured properly, because again, it depends on the way how we manage, how we deploy it, and it's really, really big amount of knowledge, which sometimes you need to find knowledge keeper around to make it happen. And again, without container orchestration platform, you cannot really manage that. So this is why Kubernetes today works with us. It schedules, heals, scales, and manages configurations. It's declarative, and it can be integrated with variety of tools, systems, and create the entire ecosystem. GitOps like Cargo CD, Helm, Istio, whatever you can name, it can be integrated with the Kubernetes. The power of Kubernetes is also incredible, but when you need more functionality and power, complexity is also becoming a little bit bigger and bigger. It is what it is. And again, every misconfiguration has its own cost implications. So sometimes you can forget to turn something down. Sometimes you do something that. We will talk a lot about that in the next section about mistakes. So again, talking about Kubernetes, to be on the same page, what we have in the Kubernetes. Pods is a minimal entity which represents one or more containers which can be scheduled anywhere. Deployments, something which manages pods and make them updatable and versioned. Services, Kubernetes service, it's something which gives stable internal address endpoint actually, which can be used by the applications or integrations within the cluster to access this group of pods. Ingress objects exposes something to the world, and nodes of the Kubernetes, it's physical or virtual infrastructure pieces, which provides the Kubernetes some resources which you can use to schedule your workloads on. And in reality, nodes is the biggest cost piece which you actually pay for. If you're using Kubernetes in cloud, you also pay for control plane, but nodes still it's some kind of biggest cost item in the Kubernetes. So Kubernetes resources is actually what Kubernetes nodes provide you. You can like explain them in 2 words. So requests and limits. Those settings define how much CPU, memory, or other resource one container need and can consume. So request, exact need, limit, maximum consumption threshold, which you set. So the Kubernetes scheduler use request numbers to decide what node it should place this pod. So the bottom line, if you don't set correctly resource request limits, pods fight for resources. Or nodes that are underutilized and other things which we will talk a little bit later. So this don't really hurt you only operationally, it also hurt you financially at the end. Beyond CPU and memory, there are also some kind of resources types like GPUs. Today it's really modern and demanded resource, storage, bandwidth, custom resources, which has less cost implication at the end. So anyway, all the things matter, and this is about the Kubernetes. Next thing we want to talk about in general, it's about autoscaling. Autoscaling is some kind of general statement, which can be 2 types. First one, vertical scaling, when we are giving more resources to one, I don't know, virtual machine or pod, it doesn't matter. And horizontal scaling, when we are adding more replicas, if we are talking about virtual machine. 1, 2, 3 more virtual machines like that. If we're talking about pods, containers, whatever, just the same copy of the same configuration. And too much vertical scaling leads to underused big pods or big nodes, and too much horizontal scaling increases node count. Balance always is the key, but again and again we will talk about later. So HPA is something which is Kubernetes. In the Kubernetes implements horizontal autoscaling for pods. It uses metrics, typically CPU or memory or some kind of custom metrics which you can also expose, and add and remove pods based on some thresholds you configured. It's really simple but really powerful because today, I don't know, 75% of production projects running can scale based on HPA, and it's more than enough for most of the cases. But still, we will talk about utilization and HPA in details later. So next thing we just will talk about today is vertical pod autoscaler, which works slightly differently. It analyzes usage in some kind of historical time frame and suggests new requests and limits for your pod from CPU and memory point of view. It's some kind of intelligent right-sizing tool which can be installed additionally into Kubernetes. It's official project, but it's not something which you can use out of the box as HPA available. So there is some kind of really simple difference between them. How it works, again, don't think that we should take a look on that right now because we will discuss it in more practical examples later. Next thing which we must say about in this kind of knowledge introduction, node scaling. Node scaling is the process of automatically adjust your infrastructure layer if needed. So when pods, let's say, can find the room to seat, the cluster adds nodes to give pods ability to be scheduled. When you don't have any usage on the node, node scaling automatic node scaling tool typically removes not needed nodes. Without these, your nodes stay idle, and again, you pay for that because for cloud providers, it doesn't really matter how much resources you really use today. If you requested big instance with 5 bit number, 8 gigabytes of RAM, and I don't know, four virtual cores, you will pay for that regardless the usage. So next area which I want to focus, it's what kind of mistakes most of us make, which I see on literally every project from the beginning when someone worked with Kubernetes without really, I don't know, either attention or good experience before. Such mistakes can be found and can be done, and you can just identify such kind of issues. So we see it every audit. So this is something let's start with. First, typical mistake, no resources at all. So launching container without specifying resources is like renting servers without knowing how much RAM or CPU you need. So if you will go to, I don't know, some computer shop and will ask to sell you a computer, they will ask what you need, because if you don't know what you need, it's exactly the case. So but Kubernetes allows you to run this kind of deployment pod without specifying resources. But in that case, Kubernetes will run it in best effort quality of service. It's some kind of internal mechanism of the Kubernetes cluster to understand the priorities of different pods in addition to everything specified in the configuration. And best effort means that those containers can be killed literally anytime if the Kubernetes will need resources dedicated for this pod for something else. That's basically it. In reality, we can see the situation when unbounded backup job, which we run from time to time, but it doesn't have any resources constraint, can take down production, which also don't have any kind of resources constraints because of variety of events inside the Kubernetes. It's really unpredictable. When you don't have resources, you really cannot guarantee what will happen with your pod. Again, some kind of remark, if we don't configure anything else, because there are also things like priority classes and stuff like that, we are saying about some simple configuration. Sometimes you can see that specification in the YAML has limits but doesn't have requests. It's a really good question. What will happen? Basically, for Kubernetes, it's not feasible to run the pod without requests when you specify the limits, because for the Kubernetes, it means that if the pod can consume, I don't know, we should configure threshold for 10 megabytes of RAM and 10 milli virtual cores. It means that we should request at least this amount of resources to make it work. This is how Kubernetes works. It automatically sets requests equal to limits if you just defines and limits and resources on the limits. Next mistake, it's no limits at all. Again, it's questionable. What kind of limits are we talking about? Because for memory, limits are the must. For CPU, they are some kind of optional. And in our practice, we configure CPU limits really, really rarely. Because in the modern systems, first of all, it's really hard to predict the CPU consumption. And cheap modern CPU are really, really powerful. They have incredible performance in context switching. So in reality, only for really specific processes which does a lot of CPU computation, you will have to configure some CPU limit again, and it's really rare. We will talk about this case a little bit later, but if you don't set any limits at all, so it means that at some point of time, this pod can consume the entire node resources. So, and when it happens, Kubernetes cannot stop it because you haven't configured any boundaries. So other pods can crash, users can see variety of status codes non-equal to 200. And your monitoring really lights up as a Christmas tree. So you always have to set boundaries, at least for memory. This is why it's really important to configure memory limit as a requirement. Because when you do set a limit, but let's say you just selected some number without calculation, what the Kubernetes does, when your process hits the memory limit, it executes out of memory killer, which literally kills the pod, and Kubernetes will restart it. So user can see random errors, and it's sometimes not really 100% clear what is happening with these pods without accessing monitoring system. So ideally, memory request and memory limits should be equal or really close to each other, because if they will be like really big difference, you can have out of memory killer on the level of node, which is also not really good because memory is some kind of fixed volume. So if you have 4 gigabytes of RAM, you cannot consume 5 gigabytes of RAM. While in CPU case, if you have 2 virtual cores, at some point you can consume even 4 because you can create some kind of queue and load average will be more than number of virtual cores. So it's like deep topic, but in general, I think that it's clear that memory is some kind of fixed resource which you cannot overuse in comparison with everything Node provides. By CPU, it's some kind of not really measurement. It's measured number. It's some kind of maximum capability of CPU to give you some computation results. But in reality, you don't consume cores, you consume compute time, which is completely different from what we see in memory case. So the bottom line that always limits for memory, ideally close to the requests of memory. Next mistake is flapping HPA and scaling in general. For instance, we have some traffic spike, then our Kubernetes scale outputs, pods are not ready, but threshold went down. So Kubernetes decides to scale everything in, and again it repeats. We create pods, but we don't use them because we have misconfigured HPA. It happens too often, trust me. So the cluster trashes itself and wastes compute all the time. It looks like the scaling, but it's actually extra noise, I would say. Why does it happen? Because of different reasons. So one of them is that we have too noisy metric. For instance, we exported some metric from Prometheus, but it's not in the proper format. Again, on next slide, I will show how we can fix it, like using PromQL rate function, actually. Second case, we misconfigured HPA in terms of stabilization window or some other settings, like policies. Or, which is really important, we misconfigured readiness props, because for the Kubernetes, readiness prop is and liveness prop is actually key indicators that pod is up and ready to accept the traffic. While those probes are failing, Kubernetes won't route the traffic to those pods, and it won't decide that those pods are ready, and it won't calculate metrics of those pods in the total metric of the HPA settings. So ideal readiness prop, it shouldn't be just health AZ, whatever. In reality, it should be it should be something concrete which returns and represents the state of your application and all the dependencies. So please make sure that your application has readiness props. It's really important. If you're using HPA, configure stabilization windows and use rate ratio metrics from Prometheus to make them smooth, and everything will be great. Next mistake is really non-technical. It's process-related mistake. It's copy-paste resources. So what we see at Naviteq on projects, that engineer often just copy-paste resource definition from other charts or ChatGPT, or in the past it was from Stack Overflow. But in reality, it's dangerous because every application has its own unique behavior, especially in concrete environment. So copy-paste leads to over-provisioning and inflated bills. That's reality. So if your app really uses, let's say, I don't know, 50 milli virtual cores, but request 500 milli virtual cores, you're wasting more than 90% of that capacity because you don't need it. But Kubernetes will reserve it for you if you requested it. So that's really invisible cost because you pay for that, but you probably don't even know that you don't need that. It's some kind of really frequently met trap. So what to do? Basically monitor everything. It's obvious. Yeah, I will show a little bit what kind of tools we have for that and use for that. From time to time, it makes sense to do some kind of profiling, ideally with performance tests used, but even basic kubectl topos with some kind of during test execution will give you some answers. How much resources do you need if you don't have Prometheus and Grafana, but it's really easy to install. Do this kind of audit on some regular basis, quarterly, 2 times a year. It's up to you what to decide. And which is really important, you must train your team and understand and give them the understanding that resource tuning is not just YAML. Again, it's really operational maturity. So if your team follows simple rules that everything configured should be configured with thinking about what they do, what kind of outcome it will lead, it's something which you need to follow, which you need to try to change your organization approach and make it work. Next mistake, and probably the last one, which we see from time to time, is that sometimes teams are not limited with any boundaries. So teams, for instance, in the cluster, which is used by multiple teams, can deploy freely without any limitation. It sounds flexible, but in reality, it's really chaos. Because if you don't have any kind of namespace level limits, if you don't have limits on the cluster level, how many nodes or how many resources you can consume, it can have direct, let's say, consequences on the real environment, which not real, but the environment you really need today. They can face some capacity issues. They can face any kind of other issues depending on the settings of your cluster. So in reality, you should always try to configure limits because resource governance is like cost control mechanism, which is base statement in the FinOps in general. So what kind of options we have here? So again, for clusters, which not only operations team manages, but also some developers can interact with that and stuff like that. It's always the good practice to configure something called limit range, which defines some kind of default settings for requests and limits if it's not specified. Again, it goes against the practice we discussed before, but sometimes for dev namespaces, it can be at least something which you can apply and stop doing unmeasurable deployments in terms of resources. Another thing, you can also configure resource quota for the enter namespaces to send the boundaries, how many resources this namespace can run in general. Also, like always label your deployments, tag your cloud infrastructure, match it, and track consumption, your billing and FinOps tools. Once you do that, like your cost visibility becomes alive and you can use it. So now let's talk about tools, because we talked about some steps without concrete recommendations. This is something more probably important and valuable. First thing I would tell you about some product which you probably not everyone familiar with, something called KEDA. It's like a third-party open source product. It stands for Kubernetes 7 driven autoscaler. It actually gives you ability to scale not only based on CPU and memory consumption, but also on some kind of custom metrics. For integrations it supports, there are a lot of them, like 50 plus, something like that. It's starting with RabbitMQ, Kafka, Prometheus, CloudWatch, cronjobs. Also, it supports CPU, memory, whatever. So you can really scale based on, I don't know, queue depth, message lock in your database, whatever, which gives you ability to scale based on real business metrics, not just CPU. Yeah, it's funny that it contains also Russian words, so because it was partially translated from Russian, so apologize for that. If you are summarizing HPA and KEDA, HPA uses internal metrics like CPU and memory. It's some kind of, we already discussed. KEDA uses external, like messages queue or PromQL, which is really important. And while we are recommending to adopt KEDA for most of the clients, is that KEDA can scale to zero pods, zero cost, because with HPA it's not feasible, because you are measuring everything based on running pods, while KEDA is measuring something on something external. So if your message queue doesn't have any messages and your pods just should be run and up and running while you have messages, why not just turn it down to scale 0, and as soon as messages will arrive, Kubernetes will spin up for you. This works like a charm. And together, because at the nutshell, like KEDA just manages HPA objects for you. And this is how it works. So this is why at some point it works together. So the bottom line, that in most of the apps, HPA is enough, but in reality, we always recommend to use KEDA for most of the clients, because you can start with KEDA, with CPU and memory metrics from the beginning, and sooner or later you will decide to make it change it, and you have already KEDA. Just do it and enjoy. VPA. VPA is exactly wonderful tool if you want to start optimizing your costs in the Kubernetes, but you don't know what to start with. Because VPA has few components. First of components, recommender. It's something which analyzes your CPU and memory consumption and gives you recommendations. Next component, updater, decides how to proceed with this recommendation. And depending on the HPA mode configured by you, it does some changes with your cluster or don't do anything if mode is off. And admission controller is some kind of advanced functionality of the Kubernetes, which helps updater to implement the logic. The logic is really simple. So metric server collects some usage, recommender analyzes that. And if it sees some kind of field of improvement, updater applies recommender posts its recommendation in the definition of the object, and updater can just ignore it if it's configured in off mode, or apply those changes automatically. So in that case, when it applies it automatically, it must restart your pod, because Kubernetes cannot change your resource constraints on running pod. And then updater just triggers rollout of your deployment or recreates the pod, and admission controller exactly what does the magic, and during starting the pod, it just applies the new resource specification. So you have manifest with fixed numbers, but in reality, it will be different if you have VPA enabled. So algorithm is really simple. So few minutes, VPA collected recommendations, auto mode, it restarted that. So we always really ask our clients before deciding that let's enable VPA in auto mode, that we are ready. From our experience for VPA in general, really good use cases, something like batch jobs, cron jobs, non-production environments, works perfectly fine even in auto mode. But you should avoid using VPA or be careful with that and understand the potential impact for stateful and single replica apps, because restart means downtime. And if your application is not capable to work in multi-replica mode, or it doesn't handle restart correctly, it can be the challenge. So VPA is brilliant, but you should treat it like scalpel, but not like hammer, because you cannot really solve any problem with that. So we always recommend on cost reduction project for Kubernetes to run it first in off mode to collect the data. If you decide to enable auto mode and make it and let it apply changes, you should configure readiness probes and pod disruption budget, something which prevents Kubernetes to be really disruptive. And when you use it carefully, VPA pays for itself and gives you significant savings. Basically, this is how it looks. We configured something which in reality consumes less resources than requested. And after some time, recommender posted this update. If we have it enabled, it even go furthermore, applies that and reports in annotations that I did this change. Basically, this is how it works. Talking about cluster, not autoscaler, which we mentioned, we have two implementations. First one, cluster autoscaler. Something works on a variety of the clouds, something which works in stable way, but something which is limited with concrete implementation. What I mean. So pod, cluster autoscaler works when pod can schedule. It adds new node automatically, but in most of the cases, it's based on auto-scaling feature on specific cloud. So it's not really flexible enough to select something suitable for your concrete request. This is why we always recommend using Carpenter, which is today 100% applied on all the projects with AWS and depending on the readiness in other clouds, because Carpenter today is available for Oracle Cloud, Azure, GCP, and few more clouds. Some of them are officially supported, some of them are created by the clients, but Carpenter takes it further. It's not just cluster autoscaler, it's just-in-time capacity management and smart instance selection approach. It picks not only the node based on your node pool, it picks the cheapest and best fitting instance on the fly. And if you're using, for instance, spots, in real case, it can reduce your reset cost by 20-50%, depending on the state of right now, in comparison with cluster autoscaler or even clusters without autoscaling for nodes at all. So talking about monitoring, it will be extremely fast, nothing really new. Start with Prometheus and Grafana, install basic node exporter, and use dashboards from Marketplace. Or use, if you are our client, we can share with you our dashboards. We have few which are really, really good. So if you want, you can also explore such tools like Kubecost or OpenCost, because you can translate your Kubernetes consumption into real dollars, because you can integrate those solutions with your cloud billing and match each other. It works not ideally, but really close to the reality. And you need to spend some time initially to integrate that, but at the end, you will have really good results. So altogether, gives you really great FinOps in action, like visibility optimization, and all the time you can analyze those dashboards and react on the reports to do continuous improvement. So this is how basic dashboard for Marketplace looks like. It just shows you some kind of information about resource consumption, utilization, stuff like that. And this is something done internally for this specific type of the project, when you can see like concrete dashboards about concrete numbers. So the first one shows you ready pods by node, and red line is some kind of total capacity of the cluster, memory request, CPU request, not memory usage and not CPU usage. Again, totally. When red line is some kind of total capacity, and you can see from this graph that before optimization, cluster is overcommitted for 50%, and even sometimes more if you compare with real usage. After optimization, applying all the tools, autoscaling case, you can have up to, I don't know, 95% of utilization of your node from the most important resource for you. This is how everything which I talked about work together. This is some, again, basic dashboard which you can use also to verify your nodes metrics, some simple dashboards from Kubecost, which shows how it works. With Kubecost, there is one challenge because it's not free anymore. OpenCost is actually open source fork of that. But even in free version, if you install Kubecost in one cluster connected with all the integrations, it can give you really beneficial insights about your infrastructure, especially if you not really feel confident in deep Kubernetes debug processes and all this YAML terminal stuff. Kubecost is the best choice for some kind of people between like business technical. It can be either understandable for technical guys and business representatives, which is really important. So really important thing, which again I mentioned, non-technical challenges. Because FinOps is not just about reducing bills. It's about creating shared responsibility model when engineering team like own and optimize their resources as part of their daily decisions. So basically, it's some kind of cultural shift. Because in traditional model, which you can see on the left side of this graph sample, centralized finance on operational teams sets company level budget limits, which is not fair because today like data team can consume 90%, tomorrow another team will consume other percent. So in FinOps model, developers are in the loop from the day one. They empowered to see and act on cost signals. They are included in the cost-related alerts escalations. All their changes also have some kind of instant feedback from the CI/CD system, what the cost implication and stuff like that. So in general, optimization is not just technical, it's organizational. So you can improve like VPA, adopt spot instances, but if your team don't care and your efforts won't scale. So you can fix something in one environment, but tomorrow in this environment, you will also have the same problem. So the R&D teams, they always like try to deliver features. It's absolutely clear. But sometimes like they prefer to set bigger requests because it's safer to share the demo. I don't know how the service will consume, or I don't know how much do we spend. I don't have access to Cost Explorer, or I don't have any feedback about wasting money, so I don't want initially to think about that, and blah, blah, blah. So ideally, everything which you can read from smart FinOps books, applicable in this case as well. So first of all, you need to make cost visible and traceable for all the team. You can create some alerts. And again, as I mentioned, include even developers in the loop of these kind of alerts, because at the end, business price is exactly what they're here to build the product. If the product costs more than it earns, it's probably some kind of thing which we need to fix together again. So you can include something like cost validation tools like TerraCost if you are using Terraform, for instance, for infrastructure in your CI/CD. Kubernetes also have some kind of frameworks which allow you to be a part of the CI/CD and give you some instant feedback even on small changes in your pull request. And again, make KPIs applied for all the teams. And again, it's unfortunately some kind of organizational decision, which requires extra management resource ownership. So someone from the top management should say, and everyone should agree, find out the solution and follow that. So few more slides and we can move to quality questions and answers. First thing, what we can do tomorrow. First of all, execute kubectl topots and analyze what you have. Compare usage, requests, limits. If you have cluster with multiple namespaces, which is used by multiple teams, enforce limit range, configure resource quotas, and start rejecting any pod without defined resources as a baseline. And install monitoring if you don't have such. Prometheus, or we personally recommend Victoria always as the most efficient way to collect metrics. And Grafana on top of that, just to show you visualization, are your new best friends. Because if you don't have it today, it's strange. If you have it, you can improve. But in reality, if you don't have some place to compare with historical data, is the problem. Because Kubernetes in reality can give you only instant result. In 1 month, what you can do, you can write or ask your AI assistant to write some load testing, execute it in some environment, non-production ideally, collect the data, and enable VPA in off mode, which will give you again useful insights about your resource consumption. If you have really a lot of workloads or you want to focus on some one namespace, you can also do it with VPA. Next, you can, I think that you're using Helm charts. If not, evaluate that and start using Helm charts and enforce templates to make resource requests and memory limits and requests mandatory. Uses required function in Helm just to make sure that it should be defined anyway. Also schedule audits quarterly, just create a ticket, which will in the next quarter and then in next quarter to just verify your consumption compared with previous iteration, improve, create tickets, implement, and continue. It's constant process which you never end. Train team just to make cost awareness a core skill and requirement for everyone. If you will go furthermore and want to improve more and more, you can implement policy as code using Gatekeeper or Kubernetes just to react from the cluster level of anything which goes in different direction which you define in policy. So you can say that again, no defaults, deny. Bad security, deny. Limits not configured, deny. So OP approach is really good thing, and policy as code is something must have for real big production environments. Next, again, create some kind of efficient KPIs, which will be some kind of target usage ratio for different teams, and make it auditable and transparent for everyone. So automate CI/CD, create alerts. This is what we discussed. And again, take this cost on the entire organization level awareness and make sure that everyone follows that. Conclusions are really simple. So Kubernetes can be efficient, and we at Naviteq know how to do it. So if you have questions, feel free to reach. And at the end, correct resources, stability, cost efficiency, and control. And again, sometimes correct resources is not only just something YAML change. Sometimes it requires application changes as well. So you should understand that if you're starting Kubernetes optimization project, you also require someone from R&D team to be a part of that. Otherwise, it won't be succeeded. So longer than I expected. Again, always fail timing, unfortunately. Let's discuss. I don't know. If you have some specific cost challenges, if you want to discuss whatever you want to discuss, write it down in the questions and I will try to comment it. For this, again, thank you. And let's take a look what we have in questions. If we have any. And I don't think that we have any. At least I don't see something.
Alex, I think that we have few. Maybe you don't see it. I'll read it. Maybe. Probably you don't see it. So we have like one.
Okay.
So yeah, we have like one question. A second. What are the easiest ways to cut Kubernetes costs without hurting performance?
Calculating costs without what?
What are the easiest ways to cut Kubernetes cost without hurting performance? What is the easiest way to cut the cost without hurting the performance?
So that's again, nobody says that you need to, I don't know, if your application consumes 2 gigabytes of RAM, I'm not saying that you should set 1 gigabyte of RAM and request. No. I'm just saying that in most of the cases, if you are afraid to have some performance issues, when your application consumes 2 gigabytes of RAM, you can request 5, which means that you will pay all the time for 2 or 3 extra. If for some reason your application has some kind of, let's say, unstable consumption, then you should work from different angle. You should work and can work from nodes point of view. So first of all, just make sure that you have at least 2 replicas. Then review what kind of node pool you have. Probably if you don't have Carpenter today, it can solve your problem partially because it can select the best fitting instance type for your specific case. And moreover, it will find the most cost efficient instance type available from the spot market, for instance. If you're afraid of using spot instances in the production, you shouldn't really be afraid because it's just a matter of readiness. Only one thing you should like to do, it's your application configuration. Make sure that you have multiple replicas, make sure that you have put disruption budget configured, and make sure that your pods are distributed across multiple availability zones. If your application is not ready to work in multi-replicas setup, not sure that you can really save the cost from the inside of the Kubernetes if your application resource consumption is not fixed and stable and your application is not scalable. Probably you just went to the Kubernetes with this application too early and you just need to focus on another application running there. And later when you will address these kind of issues, which, for instance, like example, on one of the client today, we have one backend application, which is using SQLite database, which means that in reality, we cannot scale this application horizontally effectively. But what we can do, we can just do some EFS, which will be shared disk for this specific database files across multiple replicas, and it gives us ability to horizontally scale the application. It's just an example, yeah? So there are a lot of like other options. Basically, it's some kind of unique case every time. What you have, what application you have, what the state of your application, how it's configured, a lot of questions. Basically, everything in this presentation is applicable for every project, at least to check. But not everything is applicable to apply, because if your application again is not ready to run in multiple replicas, you cannot enable scaling. You cannot enable probably VPA because it will cause downtime. So you always should be accurate in your decisions. Yeah, and again, unfortunately, yet today there is no silver bullet which can solve any problem. Really, unfortunately. So. Next, I see more questions. Okay. Did you have stories about cost benefits from applying particular feature? I mean, did you see that price spike is appeared after feature X was applied? Not really stories, because you know that every project is unique. I cannot say that it can be measured. So right now on our one of the existing running cost optimization project for the Kubernetes, we are moving step by step. And right now we are just adjusting resources and adjusting scaling configurations. And what we see that running cluster in the AWS For 2 environments, we already proceed because we are moving really slowly because we don't have full-time capacity for this cost optimization project only. For now, we cut the cost for 2 non-production clusters twice for EC2 because Carpenter now can bin pack pods better to have better utilization on one node. As far as Leonid, like our employee, I think we can show him more, but not for the audience. Next question about VPA use cases. In most cases, it seems for me that HPA is used in most cases. When we should go with VPA, can we use it with GPA-based workloads? Yes, we can. If our GPU worker is again something like batch processing and it can survive restart. And at the same time, sometimes it can require not only GPU memory, but more RAM as well. VPA can be the case. And again, vertical and horizontal scaling, it's not something for Kubernetes only. If your application and case applicable for horizontal scaling only, you cannot use VPA for sure, but you can use VPA in off mode in order to give you insights about average consumption of all the pods in your scaling group. So from my experience, like VPA works perfectly good for big applications, huge applications, let's say databases. If it's in niche mode, again, deployed by a curator, it gives a lot of insights. And for production workloads, because sometimes you can overestimate initially your consumption and create something really, really big. So yeah, I think that I answered. Some 1-3 methods using Carpenter to achieve a cost-efficient approach and also staying on the safe side. Carpenter, again, it has a lot of settings. Methods using Carpenter. First method, we are just starting using Carpenter for on-demand instances. And it can select for us better instance types based on our initial requirements. Again, it depends what we're comparing with. If you're comparing with cluster autoscaler, it gives us benefits in selection of the instances types available. Moreover, Carpenter also helps us to be on the safe side by design because we aren't using cluster autoscaler. It relies on AWS autoscaling features. And if, for instance, in one specific availability zone, the instance type is not available, autoscaling will stuck. While Carpenter, if it's not really configured with a lot of requirements, will detect that I cannot spin up M5A X large, but I can spin up M4 X large. Why not? Yes, it's previous generation of CPU, but in most of the cases, it doesn't really matter. So yeah, it's case 1. Case B, again, spot instances is also safe. If your application ready for that and it can handle exit signals, it can you configure readiness props and pod disruption budget, Carpenter will take care about everything because it has specific queue. Carpenter will be notified that instance will be taken away by the AWS pretty soon. It will take care to spin up another instance for you and reschedule your pod here. So again, spot instances is the greatest approach to save costs, and trust me, like for productions, it's not something you should avoid. We use spot instances for 95 cases of any production workloads on our clients. 5% is just something really critical. And in specific case, when application is not really good handling exit signals and any kind of interruptions can cause short downtimes, which is not feasible for the client according the SLA with end users. Oh, so yes, I think that I answered all the questions which I saw. I don't know, do we have more or not? I think that we are good. So, I don't know, time is also off. And yeah, so I think that I can just thank you all for joining and If you want to discuss anything related to Kubernetes, DevOps, cloud, or whatever you think we can be helpful, just use this email. It's actually our technical email, DevOps Naviteq, but you can open our website and find wonderful contact points of our sales and other management team if you need. Also, feel free to, like, I don't know, write a message in LinkedIn if you want to discuss something informally. I would be grateful for any kind of questions because I love this topic and love helping people. So yeah, I think that we are done. Thank you again for joining, and yeah, let's be in touch and let's meet each other on next webinars.